The James Webb Space Telescope, humanity's window into the past. The James Webb Space Telescope is one of the most ambitious scientific projects ever undertaken. Often described as a time machine, it allows humanity to peer back billions of years into the history of the universe. This telescope is designed to observe some of the oldest galaxies, revealing secrets from the very beginning of time itself. But how does it work, and why is it considered such a groundbreaking achievement? The successor to Hubble. For decades, the Hubble Space Telescope provided some of the most breathtaking images of space. From distant nebulae to galaxies millions of light-years away, Hubble changed the way we see the universe. However, as revolutionary as Hubble was, it had its limitations. Hubble primarily operates in the visible and ultraviolet spectrum, which means there are parts of the universe it cannot observe clearly. The James Webb Space Telescope, often referred to as JWST, was designed to overcome these challenges. Unlike Hubble, Webb operates in the infrared spectrum, allowing it to see through cosmic dust and observe galaxies that formed just a few 100 million years after the Big Bang. This ability makes it the most powerful telescope ever built, capable of unlocking mysteries that were once beyond our reach. How can JWST look into the past? One of the most mind-blowing aspects of JWST is its ability to look into the past. This is possible because of the way light travels. Light from distant objects takes time to reach us, meaning that when we observe a galaxy that is 13 billion light-years away, we are seeing it as it was 13 billion years ago. The farther we look, the further back in time we go. Since JWST is designed to observe in infrared light, it can detect these ancient galaxies more effectively than any telescope before it. As light from these galaxies travels through space, it gets stretched due to the expansion of the universe. This phenomenon, known as redshift, causes the light to shift from visible wavelengths to infrared. JWST's instruments are specifically designed to capture this stretched light, making it possible to study the earliest moments of the universe. A marvel of engineering. Building a telescope capable of such a feat was no easy task. JWST was a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. It took over 30 years to develop and faced multiple delays and budget overruns. The final cost of the project was nearly $10 billion, but the scientific value it provides is priceless. The telescope features a massive 6.5-meter gold-coated mirror, which is much larger than Hubble's 2.4-meter mirror. This large mirror allows it to collect more light and observe fainter and more distant objects. The entire telescope is protected by a 5-layer sunshield, which is the size of a tennis court. This sunshield is crucial because it blocks heat from the sun, allowing JWST's instruments to stay at extremely cold temperatures. If the telescope were to warm up, its infrared sensors would be blinded by its own heat. Journey to Lagrange Point 2. Unlike Hubble, which orbits the Earth, JWST was sent to a location called Lagrange Point 2, or L2. This point is about 1.5 million kilometers away from Earth, far beyond the reach of human astronauts. At this location, JWST can remain stable while keeping its sunshield between its sun and the sun, ensuring that its instruments stay cold enough to function properly. Getting to L2 was a one-shot mission. Unlike Hubble, which has been repaired and upgraded multiple times by astronauts, JWST had to work perfectly from the moment it launched. Any failure could have meant the loss of the entire mission. Fortunately, the launch and deployment of the telescope went flawlessly. The telescope successfully unfolded its massive sunshield and mirror, marking one of the most complex space deployments ever attempted. What has JWST discovered? Since its launch, JWST has already provided some of the most stunning images and groundbreaking discoveries in the history of astronomy. It has observed exoplanets in incredible detail, detecting their atmospheres and even identifying potential signs of water vapor. It has captured images of distant galaxies that existed when the universe was only a few 100 million years old, offering insights into how the first stars and galaxies formed. One of the most exciting findings has been the discovery of galaxies that seem to have formed much earlier than expected. Some of these galaxies challenge existing models of cosmic evolution, forcing scientists to rethink how the first structures in the universe came into existence. JWST has also provided breathtaking images of nebulae, revealing never-before-seen details of star-forming regions. The Carina Nebula, the Southern Ring Nebula, and Stephan's Quintet are just a few examples of JWST's ability to capture the cosmos in unprecedented clarity. The future of JWST. JWST is expected to operate for at least 10 years, but scientists hope it could last even longer. Its ability to look deep into the universe will continue to revolutionize our understanding of space. Future observations will focus on searching for habitable planets, studying black holes, and uncovering the origins of the universe itself. With each new discovery, JWST is proving to be one of the most important scientific instruments ever built. It is helping humanity answer some of the biggest questions ever asked. Where did we come from? How did the first galaxies form? Could life exist elsewhere in the universe? The James Webb Space Telescope is not just a telescope. It is a time machine, a window into the past, and a tool that is helping us uncover the secrets of the cosmos. As it continues its journey through space, the discoveries it makes will shape our understanding of the universe for generations to come, expanding our cosmic vision. Beyond its technical abilities and scientific breakthroughs, JWST represents a new era of space exploration. This telescope is not just about understanding the distant past. It is also about learning what our future in space might look like. By identifying planets with Earth-like conditions, JWST is helping pave the way for future interstellar exploration. If humanity ever expands beyond Earth, JWST will have played a crucial role in identifying our potential destinations. The sheer amount of data being collected by JWST is expected to keep astronomers busy for decades. Every image it captures, every spectrum it analyzes, contributes to a greater understanding of our universe. The telescope's ability to study the atmospheres of exoplanets could eventually help answer the age-old question of whether life exists beyond Earth. Even as scientists continue to process the information coming from JWST, the telescope itself remains a symbol of human achievement. It is a reminder of what is possible when nations collaborate, when science is prioritized, and when we push the boundaries of knowledge. The James Webb Space Telescope is not just looking into space, it is looking into the very essence of existence itself. The James Webb Space Telescope is changing the way we see the universe. It is showing us galaxies as they were billions of years ago, helping us understand the early moments of cosmic history. It is revealing new details about exoplanets, nebulae, and black holes. It is reshaping our understanding of space and time. As we continue to explore the vastness of the cosmos, JWST will remain at the forefront of discovery. The questions it seeks to answer are among the most profound in human history. Where did we come from? Are we alone? How did the universe begin? Thanks to JWST, we are closer than ever to finding out